Okay, so welcome back to another video. So in today's video we have the following product series. The product series where our indexes are dealing with only primes of p squared plus 1 divided by p squared minus 1. And this is really an interesting product series since of course we're only dealing with our index p being only prime numbers, so that gives us a little bit of a challenge. And the way we're going to do this is we're going to actually use a representation for a product series, and then we're just going to rewrite the series using a couple techniques from algebra. And there's also a special constant that you guys definitely seen before a couple times where I really mentioned in the video, and you're going to see that in just a sec. So I want to state the following, the product representation for the zeta function. So it's defined as the zeta of s, which is equal to the product of where p is only prime of 1 minus p to the negative s and then to the negative 1 power. So if we were to have that p is equal to, let's say that's our given, so p is prime, and we have that p squared plus 1 divided by p squared minus 1. What I can do from here is that if I were to divide everything by p squared, both the numerator and denominator, we get that this will be 1 plus 1 over p squared, and then divided by 1 minus 1 over p squared. So what I can do now is I can actually multiply and divide essentially this is like multiplied by 1 but then rewritten. So what I can do is, that means, like I just said, I'll multiply and divide 1 minus 1 over p squared, so that way we get our new product series. Well, the expression really should be, so I'm just rewrite some stuff again, p squared, then 1 minus 1 over p squared, then we multiplied this with 1 minus 1 over p squared, and then same thing for the denominator as well. We get that this will be a difference of squares, so then we'll get that the numerator is just 1 minus 1 over p to the power 4, and then this will be divided by, so this is just a double quantity, so this is just 1 minus 1 divided by p squared to the power square. Okay, and then we can just use this generalization from the fact is that this is just similarly equivalent to, so I'm just going to rewrite this again one more time. So I'll have 1 minus 1 over p to the 4, and then this is divided by 1 minus 1 divided by p square, quantity square. And so that'll be equal to, so this is just the inverse, or not really the inverse, the reciprocal. So that means on the numerator we're going to get that this is just the Riemann zeta. Oops. This will just be the Riemann zeta at 2, that's actually known as Basel's problem. And then in the denominator we have p to the 4, so that means this is just Riemann zeta at 4. And I'm just going to skip the calculations, but you'll see that Riemann zeta of 2, that's actually just equal to pi squared divided by 6. And so we square that. And the denominator, the Riemann zeta pi over 4, is just pi squared divided by 90. And if we do the simplification here, it actually reduces, and we get that this is actually the final answer is just equal to 5 over 2, like so. And there we have it, on final answer in this blue box. Okay, yeah, so that's a pretty neat representation over here, and that comes down to our final evaluation, right? So, okay, so yeah, that's pretty cool if you ask me.